let's first start with documenting our code a bit because it's a bit unorganized and ugly, and as soon as we start writing more code, we will simply get lost in what is happening where. So the first thing that we're doing is we are setuping our project. So setup. Here we have our initial conditions. Down here we have the pre-allocation of the x, y, and t vectors. Or actually we can do the following. Instead of having these three vectors here, we can move them up in the initial conditions along with the pre-allocation. We're going to leave the t vector down here, but we are going to add the number of points in our initial conditions. So positions of the point equals to 50, and we're going to use this down here. Now we know what is the size of our t vector. So here we can say t is equal to zeros of 1 and positions of the point. And let's just confirm that everything is working. So here we're pre-allocating our three vectors. Then we're populating our t vector here, and down here we're populating the x and y. Let's just confirm that it's working. It's working. Let's interrupt it. So continue with the documentation. So here we are finding the root, find root of that equation for the y, and roots of y show us where the motion starts and ends on the surface level. Alright, now here we are creating a time vector with linearly spaced values between the two roots of the y, between the two roots of the y equation, so that we start and end on the surface. Alright, down here we are setuping our plot. So we have plot setup and customizations. So let's move the limits down here. Here we have limits. We can also add labels and titles. So labels and titles. X label is distance in meters, and let's say font size of 13. Let's do the same thing for the Y label, just that the Y label is height, it's height. And we can also add a title, labels, titles. Alright, so this is a two-dimensional motion of a point in space. Font size, this will be a bit bigger, font size of 15. Let's run it again. Alright, we have a bit more stylings. Now we have to delete this from here, and now here we're calculating and plotting. Now we need to make our limits a bit more dynamic. We have to find the minimum, the maximum values, and add percentages on both sides like we used to do. To find our limits will be a bit tricky to make them dynamic, because we have to recalculate some of the values from the equations that we have. We have to find where is our maximum value and where are our minimum values, and use those when we define our limits. So if we run the project, you can see that we are actually getting a parabola, and we know that the parabola has its highest point in the middle. So we have to take the middle point of the parabola and use that as a maximum for the y. So let's calculate the y max. So y max, we're going to use the same equation, but we are going to simply use the middle point of the t like this, and the y minimum will be, and I have just noticed that I have a slight problem with my equations. Since these are the correct equations, but since we're breaking down the equation to x and y, and we have an angle, a starting angle, we need to use cosine and sine. We have to use cosine for the x. This is not going to change the result in any significant way, we're simply going to get a bit more different values. So here we have cosine of the angle, and here we must multiply it by the sine of the angle. And we also need to add it up here, times sine of the angle. This is because if you have x and y and you have some vector, when you break down the vector into its x and y components, the x, so if this is the vector r and you want its x components, the x component will be, here we have some angle alpha, this will be x equals to r times cosine of alpha, and the y will be r times sine of alpha. This is not really that important, it's just a slight mistake that I had in my equations. Since the velocity is actually a vector and we're breaking it down, we have to do this slight change. But as you can see, we don't have any issues, it's still working. We are simply going to get a slightly different graph in the end. That is the only change, but it's still working the exact same way. As you can see, we still start from 0, we end at 0. So this is just a slight detour. I had to make this change because I realized the problem when I started making our limits. So we need to also add the limit here, so sine of the angle. And if we substitute the y max down here and we run it, as you can see now our y max is right on the upper limit of the parabola. So now we need to modify it a bit, we need to find the rest of our limits. So as you know from previous lectures, y min will be the minimum value minus 10% of the maximum value. So what is the minimum value? We have to use the same equation, and instead of using the middle point like we do here, we are going to use the first point, so t1, and we also have to use it down here in the y lim, of course. So let's try it, and there we have it. You can see that now our y limits are correct. We start from the 0, we end at the upper point, and we will end back to the 0. Now we need to add 10% to both of these, so I'm going to simply multiply everything here by 1.1, and down here I'm going to subtract y max multiplied by 0.1. Let's try again. Alright, so we have a bit of space down here, a bit of space up here. Alright, it's working. Now do the same thing for the x limits. We're going to take the same equation and we're going to simply multiply it by 1.1, use the nth 2, this is alright, and x min will be the same equation, but we are going to use the first index of the t, and we are going to not multiply it by 1.1, but we are going to subtract x max multiplied by 0.1. So here we need a set of brackets like that. Let's try it. X max, let's run it. But we don't have to use the nth divided by 2 because our end point is at the end of the x values, so we simply need to use the last value. Down here everything should be okay now. Let's run it. And it seems like we are going to get the correct results. Alright, yes we do. We finally got our limits correctly calculated. Now, I'm going to show you, this lecture had nothing to do with loops, obviously. But what I'm going to show you now is how you can modify all of these things with loops to make everything working for different initial conditions. So we're going to add more velocities, and we're going to generate 10 different graphs for 10 different velocities. So everything that we did up until this point needs to be recalculated for the different velocities. We're going to get different limits, we're going to get different roots for the y, we're going to get many different things for the different velocities. And this is what we're going to fix in the next lecture.